Hello class, today is the 3rd of March. What we are going to do today is you guys are going to take your test. But before you take your test, if you remember, yesterday we didn't actually finish question number 5. I gave it to you guys for homework to do on your own. But at the same time, since a very similar question to this is going to be on your test, I think that I should go over it in the form of a video before I send you guys off to do your test. So I'm going to go over this, and then as soon as I'm done going over it, you guys are going to go ahead and you are going to take your test for today. So for question number 5, it says that for centuries, a mysterious sea serpent has been rumored to live at the bottom of a mysterious lake. A team of historians have used a computer program to plot the last 5 positions of the sightings. Guess what? We're going to be that computer program because they only plotted one of those points for us, and they're asking us to locate and label the locations of the last 4 sightings. A, -9.5, 0. B, -3, -4.75. C, 9, 2. And D, 8, -2.5. Now, what we are going to do for this is, once again, remember that our first coordinate is our x-coordinate, and our second coordinate is our y-coordinate. So our first coordinate is going to tell us how far to the left or right we are going to go, and our second coordinate tells us how much up or down we are going to go. So with point A, -9.5, 0, we are going to go to the left 9.5, and we are going to go up or down 0. So first to the left 9.5, 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half. So that point will be right here for point A. Let me just make sure once again. 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half. So remember that little tiny nub at the end. We have to put it halfway between -9 and -10 on our graph. Sometimes we can use a different scale, but if we were to use every half as a scale, we'd go 1, 2, 3, 4, 5 and a half, and we wouldn't be able to get to 9.5. So we're going to use a scale of 1 to 1 for this. For B, we have -3, -4.75, which means, similar to our last point, x, y, we're going to go to the left 3. This time we're going to go down 4.75. So I'm going to go down 4, and then I'm going to go down another 0.75, about 3/4 of the way down. Actually, exactly 3/4 of the way down, but my measurement might not be exactly where it needs to be. Speaking of that, we've just finished plotting point B. We have 2 more points left to plot out of the 5 points, because remember, E was already plotted for us. Next, we have to find point C, which is 9, 2. Now, since neither of these are negative, instead of going to the left, I'm going to go to the right. And instead of going down, I'm going to go up. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 2. So right there, that's going to be our point C. And then we have one last point. That's point D, which is going to be 8, -2.5. So we're going to go again to the right, but instead of going up, we're going to go down. So we'll go over 8, down 2, and then down another half, placing that point halfway between -2 and -3. So that one's going to be our point D. Part B is saying, hey, over time, most of our sightings occurred in quadrant 3. Now, Quadrant 3 is actually the really easy one. It's the easiest quadrant to remember because we can easily remember that this one is 1. And sometimes we can get a little bit confused about which one is quadrant 2. Remember, we go counterclockwise when it comes to our quadrants. So this quadrant over here is going to be quadrant number 2. However, even if for some reason we thought that this quadrant was quadrant number 2, no matter what, we'd still come to this one as being quadrant number 3, which then leaves this one as quadrant number 4. But in either case, no matter which way we went, we'd still find out that this one was quadrant 3. Now, all I need to do is pick a point that lies inside of quadrant 3. Now, obviously, it says just pick the coordinates of any point, but in order to keep with the theme of this question, I'm going to limit myself to only picking a point that's in the actual lake. So, well, that's pretty simple. I can go 1 to the left and 1 down. Remember, 1 to the left, that's -1. 1 down, that's also -1. So the coordinates of a point in quadrant 3 could be -1, -1. Any points in quadrant 3, both my x and my y are going to be negative. As we can see, I've copied the graph and placed it here. As we move on to question C, question C asks us, hey, what is the distance between point A, which we've already plotted, and the point 9.5, 0? So there's one best way to do that, and that is to look at where 9.5, 0 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a half. And obviously, since it's 0, it's going to stay on that x-axis. Here's the good news. Since both of these points are on this x-axis, I know that it is a straight horizontal line. And since they're both on other sides of 0, I can worry about my distance to get to 0 here and my distance to get to my point here, or my distance to get to 0 from there. So I can worry about my absolute values of my x coordinates. And I can add them together. So let's look at the absolute value of 9.5. Absolute value of -9.5 is going to be positive 9.5. Remember, that's our x-coordinate for point A. Our x-coordinate for this second point that they give us is positive 9.5. In fact, these points are on exact opposite sides of our y-axis, of our origin, which means they have the same absolute value of 9.5. Now, when I add these together, 9.5 plus 9.5, I am going to get the distance of 19 units. Now, we're not sure how much each unit represents. It could be a mile, it could be like 500 feet. We're not 100% sure, so we'll just label it as units. Question D asks us, hey, what are the coordinates of point E on our coordinate plane? That was the one point that we didn't plot. They had actually already plotted it for us. So instead of doing what we did in A, in terms of following the coordinates to get there, we are now going to start at the coordinate and find out how far it is from the origin. Well, to find how far it is from the origin, we need to find out how far it is from the x-axis and the y-axis. So how far it is from the y-axis, that'll tell us our x-coordinate, because it's 1, 2, 3, 4, 5 to the right of our y-axis, and since it's to the right, that's going to be positive, so positive 5. And we are 2 up from the x-axis, and since it's up, that's going to still be positive. So we are at the coordinate 5, 2. we're at the coordinate 5, 2 for point E. Now we've got 2 more parts to this question. Actually, we only have 1. I lied. Part E talks about a 6th point that we hadn't talked about yet, point F. Point F is actually related to point E. Its x-coordinate is the same as point E's, but its y-coordinate is the opposite of point E's. It asks us to locate and label point F, asks us what its coordinates are, and then asks us how far are they away from each other. So the first thing and the only thing that we know about point F so far is that its x-coordinate is the same and its y-coordinate is the opposite. So let's look at our coordinate for point E. Point E, we just said, was the point 5, 2. I'll label that as point E so that we don't get confused. And let's talk about point F. For point F, we have our x-coordinate being the same thing. That's our first coordinate. So that's going to stay as a 5. And we need to talk about the opposite of the y-coordinate. What's the opposite of 2? Now, hopefully at this point, we just know what the opposite of 2 is off the top of our heads. But if we don't, we can remember that in order to find the opposite, we need to find what's on the other side of 0 of it. So since this one is 2 above 0, aka 2 above our x-axis, we can go 2 below our x-axis in order to find it. So that right there, I'll plot it now since we've already found it, is going to be our point F. And then if I find out, well, that's 2 below the x-axis, that means we go 2 down, which is -2. And then the last thing, we've talked about its coordinates, we've located and labeled it. It asks us how far are these points from one another. Well, the first thing that we could do is, well, we could just count the jumps, and the jumps tell us there's 4. Or we could still use that previous method that we used, where we used our absolute values in order to determine distance. We don't really need to when we actually have the coordinate plane in front of us, but it's good to remember that we can do it just in case we don't. So my y-coordinate, my first one was 2. So the absolute value of 2 is equal to 2. The absolute value of -2 is equal to, well, 2. And then since these have opposite signs, originally, I'm going to add them together, and I'm going to do 2 plus 2 is equal to 4. So either just count the number of jumps, but if you don't have a coordinate grid, using the absolute value method works perfectly fine. So that is the end of question 5. Now that I've gone over it with you in this video, you should hopefully be completely prepared to go into this test. The test is going to be posted alongside this video. Don't worry, it'll be there. With that, I hope everybody has a great day. Good luck on your test, and I will see you in person on Friday.